Okay, so we have flipped over. Now we're looking at the back side. My video cut off. I don't know why, but we'll just have multiple videos to watch today. Sorry about that, guys. All right, you're going to use the scale factors and proportions to solve problems involving similar figures. So this first example, they're telling us that these two trapezoids are similar. And we need to use this information to help us find x and y. So again, it's going to be very helpful to use this similarity statement to determine which angles and which sides are going to be, angles are congruent, of course, sides are proportional. So we're going to use this to help us set up a proportion. And sometimes it's helped to color code. You can get out some coloring pencils and color the sides that correspond using these letters, like AC and VW go together. So I'm going to take AC and I'm going to color it the same as VW because those two sides are corresponding. And if I look at my similarity statement, CD corresponds to WY. Again, color coding is super helpful. You can use it or you don't have to. DF corresponds with YZ, and of course that would leave that last side, which I guess I could pick another color, and AF corresponds to VZ. So if you want to, get you some coloring crayons, colored pencils, or maybe you can just refer back to ACDF is similar to VWYZ, and you can determine which sides. I like the color coding. I'm a visual person. All right, so I need to figure out what x is. In order to figure out x, I can set up a proportion. And to do that, I start off with x because that's what I'm trying to solve. So x corresponds to side length 10. And now I need to pick two other sides. And you notice I started with figure number 1 first, and I put figure number 2 on the bottom. So that might help you as well set up a proportion because you don't want to ever flip a side over because then you got inverses and then you won't have the right answer. So I started with figure 1, so I got figure 1 over top of figure 2, if that helps you. All right, so we've got x over 10, and now I need other sides that correspond. I can't use the purple side lengths because they're 12 and 3y, and that's not going to help me. So I can use the blue side lengths because they're both numbers. So I can use 9 over 6. So if you notice, I did my figure number 1 on top and figure number 2 is on the bottom of my ratio. Together I've got a proportion I can solve. So this would give me 6x equals 90. When I divide by 6, I get 15. So x equals 15. Now to find y, I would do the same thing. I'm going to start with the side that contains the y. So I got 3y minus 1, and it's the purple side. So find the purple side of the bigger figure on top, and I've got 2. This time I've got figure 2 over figure 1. You don't have to do it that way, but I like to start with my variable term. You do not have to. Just make sure that you're writing a proportion that is a true proportion. And then again, I can use 9 and 6 again, but I started with figure 2 this time, so the blue side is 6 over the blue side of 9. So make sure you're writing a true proportion. Sometimes students get those backwards. And now I can cross multiply. So I get 9 times 3y minus 1 equals 12 times 6 is 72. Yes. Distribute 27y minus 9 equals 72. Add 9 gives us 81. Divide by 27 and we get 3. So set up a proportion and make sure that you do a true proportion. You want to make sure that you stay organized in your figures. You don't want to put 1 over 2 and then 2 over 1 because they'll be backwards. All right, so pause the video and you can try out this example here. We've got two triangles that are similar and you're going to set up a proportion to solve for x and y. And then once you think you've got your answers, you can unpause the video and see if you are correct. Again, I'm going to go through and highlight my sides that are corresponding. So JL corresponds with QS. And then we've got LM corresponds with ST. And then, of course, that leaves my last side of JM corresponds with TQ. All right, so now I'm ready to set up a proportion. I want to find x first, which is a red side. So 6x minus 3 corresponds with the other red side of 3. And now I don't want to use my yellow sides because that gives me a y, so I'm going to use the blue sides. So I've got to start with the first figure, because that's where I started with on the first ratio. So blue 4 over blue 2. Again, I'm a very visual person. Colors help me out a lot, and maybe they will you too. All right, distribute. You get 2 times 6x minus 3 equals 12. 12x minus 6 equals 12. Add the 6, gives you 18. Divide by 12, and you get a fraction of 3/2 or 1.5. They both mean the same thing. So that is what x is. To find y, I'm going to start with the side that contains the y, which is my yellow side of 3y minus 2, corresponds with the other side that's yellow, which is 5. And again, I can use the blue side of 4 and 2. Cross multiply. And distribute. Add the 4. Divide by 6, and you get y to be 4. So hopefully you got those correct, and if you didn't, you can look and see what you did incorrectly. Perimeters of similar polygons. If 2 polygons are similar, then their perimeters are proportional to the scale factor between them. So if you have similar figures, then their perimeters are going to be similar, or proportional, excuse me. Their perimeters are going to be proportional to the scale factor. So perimeters are proportional to the scale factor. So here's an example. I've got 2 figures, and they're similar because they told me so, and I need to find the scale factor and the perimeter of each one. So I can easily find the perimeter of this first one by adding up, or excuse me, the second one, because it's got all 4 sides listed. And then I can add that together very easily. So 10 plus 7 plus 8 plus 9 is going to give me 34. So the perimeter of, I guess I should identify what figure I'm looking at. NMPQ is 34. And that's going to bother me because that's not how you name a figure. I have to go around. MNPQ. All right, can't jump across my figure when I'm naming it. That just doesn't make sense. So the perimeter is 34. Next, I can use the scale factor to help me determine what the perimeter is of the smaller shape without finding all of its sides. I could definitely set up a ratio and a proportion and solve it to figure out each of the side lengths, but that's too much work. So we're going to cheat a little bit, and we're going to use the scale factor. The scale factor is going to be, let's see here, WX corresponds with, if I look in my similarity, I got WX is the first and last letter, so it corresponds with MQ, which is 8. So WX corresponds with MQ, so 4 over 8, or 8 over 4, it does not matter. But in here it actually does, because they told me the scale factor of M and PQ to X, Y, Z, W. So I do want my bigger figure on top, so that's 8 over 4, which is 2. So my scale factor is 2 in this example. And so how can we use this information to figure out the perimeter of the smaller one, you ask? Easy. So we can say the perimeter of the MNPQ is 34, and we don't know the perimeter of the small shape. The scale factor is 2 to 1. So we are using the perimeter and the scale factor to figure out the perimeter of the smaller shape that we don't have all the sides for. Cross multiply gives you 2x equals 34. Divide by 2, and you get a perimeter of 17. So now I know that the perimeter of X, Y, Z, W is 17. Pretty nifty. So now I have the perimeter of each. The first one was easy because they gave me all 4 sides. Find the scale factor. Use that scale factor to set up a proportion so you can find the perimeter of the missing other figure. All right, hopefully that was helpful. Sorry I had to chop that into 2 videos there, but it stopped recording. So you have basically 3 videos to watch this week. You'll be okay. All right, use that information. Hopefully you took good notes, and you have a Google Slides that you need to complete, and make sure that you mark done when you get that done so I can check it, or send you guys the answer key for that so you can check it. All right, let me know if you have any questions. Bye.